Welcome back to Quarter 2, Physics 1, Quarter 2, Module 1 in Physics Online. There we go. All right. Let's go ahead and switch screens. We are going to start playing with the equation a little bit, the universal mathematical equation or universal gravitational equation. So the force of gravity is equal to the gravitational constant, which is 6.67 times 10 to the negative 11th times mass 1 times mass 2 divided by our radius squared. Okay, so that means that this 6.67 times 10 to the negative 11 times, we're going to say 10,000 kilograms times 10,000 kilograms, and we're going to say that it's one meter apart. So 1 meter, and that's squared because our radius is squared. 1 squared is 1. That doesn't change. I'm going to bring this up just a little bit there. Okay. So I've got 6.6 times 10 to the negative 11. And I've got, let's see here, let's do our calculator. I believe that's 100 million, but let's do the math. Okay, times equals 100 million is correct. And that's kilograms squared. It's kilograms squared because we took kilograms and multiplied it by kilograms. And then we're going to divide this by 1 meter squared, where that remains the same, so it's just divided by meters squared. Okay. Now let's multiply this and that. Okay. Let's grab our calculator. Now we're going to have to do this a little bit backwards. We're going to say that 11 negative, we're going to use the 10 to the power. We're going to then multiply that by 6.67, which equals that, and then we're going to multiply that by 100 million. So 1, 2, 3, 1, 2, 3, 1, 2, 3, there we go. And we're going to say equals, and that equals 0.00667. That is equal to 0.00667. What are our units? Well, the units for the universal constant is newtons, meters squared, kilograms divided by kilograms squared. So our kilograms squared cancel, and our meter squared cancel, and we just end up with newtons. And that's good because we are looking for a force, and newtons is a force. Okay, so that's our force. What happens if we double that force? So we should be able to just say 100,000, 100 million, and we're going to double that. Should be 200 million. We're going to keep the distance the same. Okay. And the 6.6 times 10 to the negative 11 newtons, meters squared, kilograms squared. And this is meters squared, kilograms squared. So again, our kilogram and our meter squared cancel. Okay. So let's go ahead and do the math again. Let's pull this back down. And we have 11 negative there times 6.67 equals times 200 million kilograms, and our answer is 0.01334 newtons. Okay? So what's the relationship between this and this? Okay? So if I take this, maybe, come on, and I'm going to go ahead and divide that by 2. And notice I get the exact same answer. So if I were to take my answer here and multiply it by 2, I get that. So if I double my mass, I double my force. Okay? Doubling the mass doubles the force. Okay? Now that's assuming that my radius doesn't change. Double the mass doubles the force, provided the radius doesn't change. Okay. Double mass, double force if the radius or the distance between the two masses doesn't change. Okay. Awesome. I will see you guys in the next video. Again, I'm glad you're here. See you in a second.